So in section 9.2, we're going to focus on performing mole-to-mole calculations. And if you remember that the conversion factor we're going to need for doing these types of calculations is what we call the mole ratio. And what mole ratios look like are moles of one thing divided by moles of another. So that's it. So it might look like something like this, where you have 3 moles of A for every 2 moles of B. So if I multiply this by 2 moles of B, you can see what happens. It turns it into moles of A. Alright, so we use this to do what we call a mole-to-mole calculation. It takes moles of one thing and turns it into moles of another thing. So how do we get these mole ratios? Well, we get them from reaction and formula coefficients. So here's a balanced equation. Your equation must be balanced before you can begin to create mole ratios. And if I look at a formula, I can see that within methane, you get 4 moles of hydrogen for every 1 mole of carbon. You see, that's using what we call formula coefficients to generate the mole ratio. I can also use the reaction coefficient. So we've got the reaction coefficients here of 1, 2, 1, 2 to generate mole ratios. So for example, according to this balanced equation, I require 2 moles of O2 to react for every 1 mole of methane that reacts. You can also see that for every 1 mole of CO2 that is produced, 1 mole of methane must react. Similarly, for every 2 moles of water that are produced, 1 mole of methane must react. And for any pair of things in this balanced chemical equation, I can create mole ratios in that manner. And these mole ratios allow me to convert from moles of one thing to moles of another thing. And as mentioned previously, whenever we're going from amount of one substance to amount of another, you can see we've always got to go through moles. There's no way of directly going through grams. So like I said previously, the first step in many calculations is to convert the amounts of all of your substances into moles. Okay, so one way we can use this is we can take a balanced equation and determine how much product can be formed from a given amount of reactant. So in this case, we can say if 2 moles of methane is reacted with oxygen, how much H2O is produced? So this is an example of a moles of A to moles of B calculation. So I've got 2 moles of methane and I want to know how many moles of water can be produced. So N is often used, a lowercase n is often used to indicate the number of moles of something, and I've done that here. So the number of moles of water is equal to 2 moles of methane, and we know we're going to use a mole ratio to do this moles of A to moles of B. So our mole ratio, we want it to have moles of methane on the bottom there so that they cancel out, and then it's going to have moles of water on the top line. And you can see from our balanced equation we get 2 moles of water for every 1 mole of methane. So we're going to end up with 4 moles of water, and I know I've got it right because when I cancel my units, the only thing that's left over is moles of water. So it worked out perfect. Remember, the abbreviation for mole for moles is MOL, mole. Okay, so that's really how it works. We could do that for any 2 things that were in our chemical equation. So let's have a look at an Alex type problem based on this idea. It says gaseous ammonia, so that's NH3 gas, reacts, so it's telling you that it's on the left hand side of the arrow, with O2. Okay, O2, and that's also a gas, to produce, so now we're talking about products, nitrogen monoxide gas and water, and it says vapor, so that is also a gas. So we need to balance this, and the big thing that I can see is that my hydrogens don't balance, do they? So I'm going to put a 2 there, and then that'll bring that up to 6, and then I'm going to put a 3 there. And then I can see now that my hydrogens and my hydrogens now balance. So hydrogens 2 times 3 is 6, hydrogens 3 times 2 is 6, so they now balance. But the difficulty is my nitrogens don't balance. On the left I've got 2, and on the right I've got 1. So I'm going to need a 2 there, aren't I? And then now nitrogens balance. So what about oxygens? Well, on the left I've got 2, and on the right I've got 2, and then another 3, I've got 5. So I'm going to have to multiply that by 5 on 2, which of course causes an issue because I don't want fractional coefficients. So I'm going to have to now multiply everything by 2, and then now it balances. All right, so let's just go through and see what we've got. The first thing I'm going to check is, would it be possible to reduce these set of coefficients? It's not, because that is the smallest, there's no common multiple there. Okay, so on the left here I've got 4 nitrogens, and on the right here I've got 4 nitrogens. On the left here I've got 4 times 3, I've got 12 hydrogens, and on the right I've got 6 times 2, I've got 12 hydrogens. So there's only one last thing to check, which is the oxygens. 5 times 2 is 10. And then over here I've got 4 times 1, so that's 4, and then I got another 6, so that also equals 10, so everything balances. So my coefficients here are going to be 4 moles of ammonia react with 5 moles of O2 to give 4 moles of NO and 6 moles of H2O. So now it says calculate the moles of water vapor. So I want the number of moles of H2O produced by the reaction of 0.6 moles of ammonia. So I got 0.6 mole of ammonia, and I want to turn that into moles of water vapor. So I've got to multiply by the mole ratio. So I want moles of H2O on the top, and I want moles of ammonia on the bottom, and now I've got to pull out my coefficient. So it's 6 moles of water for every 4 moles of ammonia. Moles of ammonia cancel out, leaving moles of water. So it's going to be 0.6 times 6 on 4. 0.6 times 6 on 4. And it looks like we need 3 sig figs. So that ended up being 0.900 mole of water. So there's my answer there. Be sure your answer has a unit symbol. The unit symbol is mole, and if necessary, round to 3 significant figures. We rounded it to 3 significant figures. Okay, all right. So that's really it. There is a way of speeding this up, I guess, with the balancing. Is that there are lots of chemical equation balances online where you put in the unbalanced equation, and it will balance it for you, and you might want to check some of those out. But there's a whole bunch of those. Just do a Google search and find one that you're comfortable using. Okay, so that concludes this section on mole-to-mole calculations, and I hope you found the video helpful.